Hello friends, earlier we have discussed about the mirror formula, magnification and refraction, about the lateral shift also, and one more interesting case about the refraction, that is the relation between real depth and virtual depth. Now, the same way, today we are discussing about some more examples from the exercise. Then exercise number 1. The question is, the one small candle 2.5 centimeter in size is placed at 27 centimeter in front of concave mirror of radius of curvature 36 centimeter. At what distance from the mirror should a screen be placed in order to obtain sharp image? Describe the nature and size of the image. If candle is moved closer to the mirror, how would the screen have to be moved? Here, the specially first of all concentrate on type of the mirror. Here given as a concave mirror, and remember the sign convention for the concave mirror. Here given as a radius of curvature and object distance given and about the height of the object is given. Our interest to calculate image distance. Then after our interest to calculate nature, matlab type of the image and about the size of the image that we can calculate from magnification. And at last, if the candle is moved closer to the mirror, then what about the screen should be moved? Initially, for the concave mirror, we can say radius of curvature minus 36 centimeter. That's why focal length it's half, means minus 18 centimeter. Object distance given as a 27. According to the sign convention, u is equal to minus 27 centimeter, and height of the candle is given as a 2.5 centimeter. रिमेंबर फ्रेंड्स वंस अगेन कि जिसकी हमें कैलकुलेशन करनी है उसमें कभी भी हम साइन कन्वेंशन नहीं लगाएंगे. और इंटरेस्ट टू कैलकुलेट इमेज डिस्टेंस, तो इमेज डिस्टेंस हमें साइन कन्वेंशन के साथ मिलेगा. फॉर दैट यूज द मिरर इक्वेशन. द मिरर इक्वेशन इज 1/f इज इक्वल टू 1/v प्लस 1/u. दैट मेक्स सब्जेक्ट 1/v. That's why 1/f minus 1/u, and make subject v, that earlier we have discussed. That's why v is equal to uf upon u minus f. Just put up all values. U as a minus 27, f as minus 18. That's why do the necessary calculation and we can get image distance as a minus 54 centimeter. Here negative sign indicate image is on the same side of object, and we can say image is obtained 54 centimeter from the mirror. That's why we can say screen must be placed 54 centimeter from the mirror. Here negative sign also indicate that image is inverted. That we can also decide from magnification. The magnification formula m is equal to minus v by u. V we got as a minus 54, u given as a minus 27. That's why magnification is minus 2. Here negative sign of the magnification, we can say type of the image is real and inverted, which is at 54 centimeter from the mirror. Now whenever our interest to calculate height of the image, then use the formula magnification is h dash upon h. From that we can calculate h dash, that is magnification minus 2. Height of the candle given 2.5. That's why height is minus 5 centimeter. Minus 5 indicate inverted, which is below the principal axis. Now the candle is moving towards the mirror, then screen should be taken away from the mirror to get fine image. जैसे हमने साइन कन्वेंशन में यूज किया है कि whenever object is moving towards to the mirror, the image is moving away from the mirror up to its focus. That's why whenever candle is moving towards to the mirror, then image is moving away from the mirror. That's why screen should be taken away from the mirror. The same way, exercise 9.2. A 4.5 centimeter needle is placed 12 centimeter away from the convex mirror of focal length 15 centimeter. Give the location of the image and magnification. Describe what happens as the needle is moved farther from the mirror. Here, first of all, concentrate on mirror. Here given as a convex mirror. That's why use the sign convection for convex mirror. That's why the focal length is 15 centimeter, positive 15 centimeter, object distance minus 12 centimeter, and height 4.5 centimeter given. Using mirror formula, we can say V is equal to UF upon U minus F. ये इक्वेशन डायरेक्ट भी हम यूज़ कर सकते हैं. अदरवाइज इफ़ यू आर नॉट रिमेंबरिंग डायरेक्टली, देन यूज़ मिरर फार्मूला, मेन मिरर फार्मूला 1/f इज इक्वल टू 1/v प्लस 1/u. उससे ईजिली मिल जाएगा ये कि v इज इक्वल टू UF अपॉन U माइनस F. जस्ट सब्स्टिट्यूट ऑल वैल्यूज, then we can get 6.7, positive 6.7 centimeter. That's why image for behind the mirror at 6.7 centimeter from the mirror. Now let's check about the magnification from minus V by U. We got 6.7, U as a minus 12, the negative negative positive, the magnification is 0.558. The positive sign of the magnification indicate image is image is virtual and erect. Now height of the image, then height of the image h dash is equal to m into h. That's why it is 2.51 centimeter. Now whenever needle is moving away from the mirror, image is also moving away from the mirror. Just check about the convex mirror. Just take the example for the convex mirror as a side glass of vehicles. Whenever object is moving towards to you, means towards to the mirror, then image is also moving towards to the mirror. Whenever object is moving away from you, matlab convex mirror, then image is also moving away from the convex mirror. That's why whenever needle is moving away from the mirror, then image is also moving away from the mirror. Now about the exercise 9.3. The tank is filled with the water of height 12.5 centimeter. The apparent depth of the needle lying at bottom of the tank is measured by microscope to be 9.4 centimeter. What is the refractive index of the water? Once again, here the tank is filled with the water of height 12.5 centimeter. That means the real height given as a 12.5 centimeter. Apparent depth given, that is 9.4 centimeter, and asks about the refractive index of the water. And in second part, if water is replaced by the liquid of refractive index 1.63 up to the same height, by what distance would the microscope have to be moved to focus the needle again? That means initially the microscope is focused at 9.4 centimeter. That is apparent depth is given, virtual depth is given, real depth given as a 12.5 centimeter. From that easily we can calculate the refractive index of the water. अब अगर वो लिक्विड को चेंज कर दे, रिप्लेस कर दे ऑफ अनदर लिक्विड ऑफ रिफ्रैक्टिव इंडेक्स 1.63, तब हमें उसकी अगेन अनदर वर्चुअल डेप्थ मिलेगी, और वो वर्चुअल डेप्थ का जो डिफरेंस होगा वहाँ पर हमें माइक्रोस्कोप मूव करना पड़े. दैट्स वाई use initially HO, height of the object as a 12.5 centimeter, height of the image as a 9.4 centimeter. Consider the refractive index of water is eta. That's why using HI upon HO is equal to eta observer upon eta object. Height of image given 9.4, height of object given 12.5. Observer obviously in air, that's why 1 upon eta. Just make subject eta, then easily we can get 1.33. The refractive index of water is 1.33. Now in second part, whenever liquid of refractive index 1.63 is filled in place of water, then no change in real depth, मतलब real depth होगी 12.5 centimeter, but virtual depth will be changed. That's why HI upon HO, otherwise consider HI dash upon HO dash, is equal to 1 upon 1.63. ऊपर observer, नीचे object. That's why HI dash is equal to HO dash, that is 12.5 centimeter upon 1.63, that is 7.67 centimeter. Initially, the microscope was focused at 9.4 centimeter. Whenever the water is replaced by the refractive index 1.63, then the microscope is focused at 7.67 centimeter to see the image of the needle. That's why the change in position of the microscope is 9.4 minus 7.67, that is 1.73. माइक्रोस्कोप को 1.73 सेंटीमीटर जितना डिस्प्लेस करना पड़े. Now about the exercise 9.4. The three diagrams are given. In first, there is an interface of air and glass. In second, there is an interface of air and water. And third, water and glass. Here, for first, for air, angle of incidence given 60 degree, and for glass, angle of refraction given 35 degree. Here, the refractive index of glass and water is not mentioned. That's why from first two figures easily we can calculate the refractive index of glass and refractive index of water. That will be used for the third diagram. In that, angle of incidence for water is given and angle of refraction for the glass has to be calculated. That's why in figure A, there is a air glass interface. Just consider refractive index of air eta 1 as a 1 and eta 2 as a eta g. Then using Snell's law, eta 1 sin 60 is equal to eta 2 sin 35 degree. Sin 60 की वैल्यू we know that it is √3/2. इसकी कैलकुलेशन करो तो मिलेगा 0.8660, and sin 35 degree just see from the table of natural sine. Then easily we can calculate eta 2 means refractive index of glass, that is 1.51. Now for the second figure, there is an interface of air water. Here consider eta 2 as a eta w. Using same Snell's law, we can get eta w is equal to 1.18. The both will be used for the third diagram, where there is an interface of water and glass. For water, angle of incidence given. For glass, angle of refraction has to be calculated. Then once again use the Snell's law. Eta w sin 45 is equal to eta g sin r. Just make subject sin r. That's why eta w upon eta g into sin 45. Substitute all values. Refractive index of water हमें मिला है 1.18. Refractive index of glass मिला है 1.51 and sin 45 degree is 1/√2. सभी कैलकुलेशन करो तो मिलेगा 0.5548. That's why अगर 0.5548 साइन के टेबल में दिखे तो हमें मिलेगा 38.68 डिग्री। जस्ट चेक इट फ्रेंड्स कि 0.5548 साइन के टेबल में कितना मिल रहा है हमें, दैट इज 38.68 डिग्री। नाउ from exercise 9.31, the question is light incident normally on the plane mirror attached to the galvanometer coil retrace backwards as shown in the figure 9.33. So in 9.33 here the black line shows that the ray is incident on the mirror, that is M. It is incident perpendicularly, then angle of incidence 0, that's why angle of reflection also 0. The reflected ray is reflected in same way, इसलिए लिखा है कि it is retraced backward as on the figure. A current in the coil produce a deflection of 3.5 degree of the mirror. तो मिरर जो भी डिफ्लेक्टेड है वो ब्लू लाइन से डॉटेड लाइन से इंडिकेट किया और उसका एंगल कितना 3.5 डिग्री. देन व्हाट इज द डिस्प्लेसमेंट ऑफ द रिफ्लेक्टेड स्पॉट ऑफ द लाइट ऑन द स्क्रीन प्लेस एट 1.5 मीटर अवे. इनिशियली जो भी गैल्वेनोमीटर पर जो भी मिरर रखा हुआ है उसमें अगर नॉर्मली लाइन इंसिडेंट करे तो उसका जो भी स्पॉट हमें उसी पोजीशन पर मिलेगा बिकॉज इट इज रिफ्लेक्टेड बाय द सेम वे. बट whenever the mirror is reflected by 3.5 डिग्री, तो हमें याद है फ्रेंड्स आगे हमने डिस्कशन कर रखा है कि whenever the mirror is rotated by angle theta then the reflected light is rotated by 2 theta with the same line. That's why जो भी एरो के साथ जो भी ब्लू लाइन इंडिकेट की है उसका एंगल होगा 2 थीटा. तब हमें ऊपर जो लेफ्ट हैंड साइड डी डिस्टेंस है वो फाइंड करना है. जस्ट चेक इट फ्रॉम द डायग्राम. द डॉटेड लाइन इंडिकेट मिरर विच इज डिफ्लेक्टेड बाय 2 थीटा. दैट्स व्हाई द रिफ्लेक्टेड लाइट इज रिफ्लेक्टेड बाय एंगल 2 थीटा with respect to initial ray. That's why theta is 3.5 degree. So 2 theta 7 degree. Just consider 1.5 meter as a capital D. Then from figure if we use the tan function then tan 2 theta is equal to D upon 1.5 opposite upon adjacent. D हमें चाहिए तो इसको सब्जेक्ट बना दो and just see the tan टेबल नेचुरल tan जिसमें 7 डिग्री की वैल्यू देखो इट इज 0.1227. दैट्स वाई D is 0.184 meter. Initially the distance given in meter, that's why we will get 0.184 meter. अगर सेंटीमीटर में चाहिए तो 100 से मल्टीप्लाई कर दो देन 18.4 सेंटीमीटर. थैंक यू फ्रेंड्स.